All right, so one of the very important topics for NEET, JEE, and your upcoming examination, if you're in class 12th, is the topic of atoms which are hydrogen-like. These atoms are called as hydrogenic atoms. The key quality of these atoms is that there is only one electron left in the orbit and rest of the electrons are stripped off. For example, you can have beryllium ion, you can have lithium ion, you can have helium ion. When I say helium ion, what I do is I strip off one electron from it and only one electron is left, which is same as hydrogen. So all the names I took, helium, lithium, beryllium, are example of hydrogen-like atoms or hydrogenic atoms. After this video, I'm going to talk about what happens when an atom such as lithium, beryllium, helium becomes an ion and mimics or comes closer to what hydrogen is. Hydrogen has only one electron, and all these ions I've just spoken about also have one electron. But something else happens in these hydrogen-like atoms or ions we should be aware of. So let's talk about hydrogenic atoms in the upcoming video, which will follow this conversation. Thank you very much. So let's talk about the hydrogenic atoms. Okay, very important topic for your NEET and JEE. Okay. All right. So, and also for your upcoming school examination. So let's talk about So what happens is if you have helium, for example, and it's an ion, and it is left with only one electron. So this is an example of an ion which is hydrogen-like. So it's a hydrogenic atom. Now, what's so special about these atoms is that you need to do some scaling up. So if you remember, the energy of hydrogen atom, where Z is equal to 1, is given by minus 13.6 upon n square. So Z is equal to 1. And when you are talking about a hydrogen-like atom, which is helium, for example, now you have to take the atomic number. But remember, you need to do something called as energy scaling. Okay, so you need to do something like energy scaling. Now, what is energy scaling? Energy scaling is, if you look into the helium nucleus, and then you look into the electron, the helium nucleus is actually more positive than the nucleus of the hydrogen. So this is the nucleus of the hydrogen, and hydrogen has only one proton in it. So you have one proton here, but you have two protons here. Okay, this is helium and this is hydrogen. So Z is equal to 2. Now this Z which gets introduced, what happens is the energy needs to be scaled, which means the energy when it's a hydrogen-like atom is given by minus 13.6 into Z square upon n square. So you get a multiple of Z square, which is not present in hydrogen. So in the case of hydrogen, Z square becomes 1. And this process of multiplying this quantity, which is this quantity, with Z square is called as the process of energy scaling. Now, what is the physical significance of energy scaling? Now, what it means is that the energy required to remove the electron from the orbit, the only electron from the orbit, will become many folds. In fact, it will become Z squared times. The reason is now the nucleus is more positive, in fact, double positive as compared to hydrogen. So this is hydrogen and this is helium. It has two protons. So it is more positive, and therefore the attractive force between this electron and the nucleus is, very high and becomes, Z times. So this is another consequence, that the force, Coulombic force between the electron and the nucleus becomes Z times, because the charge on the nucleus, positive charge on the nucleus, is more. And this represents your number of protons and therefore the positive charge. So this force which I've written here is because of just the hydrogen atom. And if you take a hydrogen-like atom, you will have to do scaling up of force also. So this is scaling up of force, okay? Scaling up of force. This is another scaling, yet another scaling you do in Coulombic force. Energy is one more which you do. Energy of the electron in nth orbit when it is bound by a hydrogen-like atom. This is the expression that you need to use. If it is a hydrogen, use this. So you can expect a numerical in JEE mains and NEET on the topic of hydrogen-like atoms. This is very, very important topic. A lot of students don't know, how do you scale up the energy, how do you scale up the force, and tend to do mistake in this question. And while you're preparing for physics, the time which is left is very, very less now. It is very important that you start doing, some sample papers and start, revising the previous chapters very vigorously, because the time left is very, very less. So go ahead with full confidence, full steam, and hopefully you will be successful. Thank you very much for your time, and wait for my next video. Thank you very much.